Okay, here's problem number 5 from assignment number 7. An open rectangular box with a square base is made out of 48 square feet of material. I'm going to stop there, and I'm just going to write down what I know given that statement. Well, first of all, I'm going to draw me a box. Here's a box. All right, and it's got a square base, which means the two edges on the bottom both have to be of dimension x. Okay, and then its height, let's call that y. All right, and now I'm going to put in, hey, it's got a total area, total amount of material is 48, which means that x squared plus 4 times xy is equal to 48. Those are the 5 sides of this open box. Is everyone okay with what I've done so far? Yeah. Now, I don't know where the rest of this question is going, but I at least summarize what's going on so far. Let's go on to the second sentence. What dimensions will result in a box with the largest possible volume? There's a typo there, not my typo. All right. Okay, so we're looking at maximizing or minimizing a volume. So let's write out a function, currently a function of x and y, for the volume of that box. And I would say that it's going to be x squared y. Is everyone in agreement there? Yeah. Now, I want to maximize this volume, but I got a problem, and that function is a function of 2 variables. And we don't know how to deal with that in this class. So we're going to chop this down into a function of 1 variable. Meaning, I want to take this restriction equation and use it to change this volume function as a function of 1 variable. I want to solve for either x or y.
Solve for x squared.
Solve for x squared.
Wow,
You know what? If I didn't have that x there,
oh, yeah, never mind.
I would say yeah, Andrew. But I'm going to say no. Or I could say nay. That sounds like a horse. All right.
Solve for y.
So let's solve for y. So I get 4xy is equal to 48 minus x squared, or y is equal to 48 minus x squared over 4x. Are we all agreed there? So that means when I take this information back, I get volume is a function of x, and it's equal to x squared multiplied by 48 minus x squared over 4x. Or, after canceling this x and one of those x's out, I've got 48x minus x cubed over 4. Oh, maybe even easier. 12x minus 1/4 x cubed. I think that's something I can work with. How about you? Can I? Well, I was multiplying the 2. Yeah, I think those are both legit moves. Right? Now, what's our typical next step? Take the derivative, set it equal to 0. So let's find out what v prime of x is. It is 12 minus 3 quarters x squared. Double check that for me, please. Let's set that equal to 0. And we'll use the main method for finishing this off. Instead of trying to factor it, I'll just separate them and take the square root of it. So I get 12 is equal to 3/4 x squared. How about we multiply both sides by 4/3? And I get 4 times 12 over 3 is equal to x squared. That cancels. Oh, sorry.
48 thirds and then it's just 16.
Okay, so 16 is equal to x squared, which means that x is equal to plus or minus 4. But of course, we can ignore the negative version of that because we can't make a box with negative side lengths. If we could, that'd be really cool. But we can't. All right. So x is going to be 4 X is going to be 4 feet. And what about our Y dimension? Plug it back into this one. So Y is equal to 48 minus 4 squared over 4 times 4. That's 48 minus 16 over 16. That's 32 over 16. That is 2. And I think that's it. How's that? All right. Let's close that recording.